Hi, my name is Leo, and my URK is URK24CO 2005, and this is Data Structures and Algorithms Laboratory second experiment, which is implementation of implementation of linear queue and circular queue using array and data structures. So what is queue? A queue is a data structure. It is a linear data structure which follows FIFO principle, which is first in first out principle. So the what is the meaning of first in first out principle is, so the element which is given in the first, the element which is inserted in the queue is which is first will be taken as the output in first. For example, the real application of queue in real life is like, if we go to a hospital, the first one who is standing in the queue will be served as first. So that's a real life example of queue. So we have two types of queues. One is a linear queue and one is a circular queue. So so the 2A represents linear queue, and in this code, which is 2B, which is a circular queue. So in a linear queue, like we in both the queue we'll be using two variables, which is called front and rear. The rear variable is used to insert the elements in the queue, and the front variable is used to delete the elements from the queue. So inserting elements in queue is called the enqueue operations, as you can see here, and deleting elements in a queue is called dequeue element. So in a linear queue using an array, front and rear move only forward. They can't reverse back. If front and rear moves forward, it can't reverse back. After several dequeues, empty slots at the beginning, it's not reused easily. The After once the front and rear moves to the next, the empty slots after dequeuing, which will be available in the first, it can't be reused until the queue is empty. So this is a disadvantage in the linear queue. But in circular queue, the array is treated like a circle. We move the front and rear value with modulo operation, so that the free slots can be reusable automatically. So this is the advantage of the circular queue. So as you can see here, initially the front and rear variables will be -1, because it represents that the queue is empty. If the front and rear value is -1, that is, the queue is empty. So over here we can see we have 6 functions: enqueue, dequeue. Enqueue is used to insert elements in queue, dequeue is used to dequeue the values in queue. So as you can see, once I run the code, so this is first, if I give display, the queue is empty because I didn't insert any values. So the first one I am inserting 10, and it's okay. So over here you can see I have inserted 3 values in the queue. So if I try to insert one more element, it'll be telling sorry, I have given 60 in the entry of choice. So if I give one more element, as you can see, as you can see, if I try to insert one more element, it says queue overflow, which means the size of the queue is 3 and 3 elements are already inside the queue, so I can't add any more elements. So dequeue, what it does is it deletes only from the starting of the element. So here you can see I have 10, 20, 30. 10 is the first element which I have inserted in the queue. So while deleting the elements, it starts from the 10. So if I give 2, the 10 will be dequeued, and if I display the 20, 30, if I again dequeue, 20 will be dequeued. So the peak function, which prints me the first element in the last element in the queue. So as you can see, the 20, 30 is the 2 elements which I have in queue, and the last element is called the 30, which is called the front element. So as we delete from the queue, the front element will be get incremented. So initially when we start to delete the values in a queue, the front will be in 0. So from deleting one by one, the front element will be getting increased. So the fifth and sixth function, is empty or is full, is used to check whether the queue is empty or not. So as you can see, the queue is not empty because I have only one value in the queue. And similarly, the queue is not full because I have only one value in two. So this is the linear queue. So in circular queue, as you can see, we represent the values. We represent the queue in which a way that the modulo function here is used to insert elements even after dequeue. So once if the front and rear elements move from the -1 initial value, and after several dequeues, the first initial free slots will be not reused in the linear queue, but using the modulo functions, we can be able to find the value. So as you can see over here, this function, this formula helps us to insert the values in the queue even after dequeuing the front elements. So as you can see, similarly, I'm inserting 3 values. So here you can see queue overflow because my stack size is 2, so only 2 elements will be 10 and 20 will be here. So similarly, if I want to dequeue, I have dequeued. So if I want to enqueue also, I can be including. So this is advantage. Similarly, the peak display function, which I have talked earlier, which is similar. So this is the second experiment of data sensor structures.